Good evening, everyone, and a very warm welcome to the Royal Society of Edinburgh this evening. It's good to see such a full audience, and we do have some people in the Overspill as well. So it's a tribute to the lecture title and to the speaker, I'm sure. People who are here for the first time, what is the Royal Society of Edinburgh? Well, the Royal Society of Edinburgh is many, many things, and I'm not going to describe what these all are, but essentially, now, the Royal Society is at the heart of all major issues to do with science, society, the arts and humanities. That's what we are. And we do that through the excellence of the appointment of our fellowship, who represent all of these different branches of knowledge and research. And we give advice to government, and we comment on all these major issues. And one of them tonight is about the interface between science and culture. Very, very important interface. And we have an excellent lecturer to do that. The lecture has been made possible by the Beltane programme, which came out of the University of Edinburgh, but has now spread to many other universities, particularly in Edinburgh, but also in certain other centres in Scotland. And it is about engagement. It's about the ability to engage with audiences like yourselves, but all over Scotland, on major issues. Actually, the term Beltane is a very old Celtic term, and it's a very old Celtic term describing an annual festival, and the annual festival, believe it or not, was celebrated around the lighting of a large number of bonfires. So it's appropriate that this has come shortly after Guy Fawkes Night, and a collecting of cattle around the fires to protect the community against pestilence. That was the idea, and it was done in May. I'm not sure whether this was, beacons, spreading knowledge, communication. I've got the right theme. So that's what's happened. That's the origin of the programme, and we're very grateful to the Edinburgh team for the success that they've done. And Professor Aubrey is going to be our speaker. He has a tremendous record of work in the area of communication, and we're all aware of that through his television work, his radio work, his numerous books and publications and lectures all around the world. He has a very distinguished background. He was made a fellow of this Royal Society of Edinburgh in the early 1970s, but has since become a fellow and been awarded doctorates and so on from many other universities. So it's a great pleasure to welcome Aubrey this evening, and he is going to deliver his lecture, which is about communicating science as culture. Aubrey, over to you. Thank you.
Well, President, ladies and gentlemen, it's an especial honour to get this Beltane Prize and to know that it's the first. So this is a new honour which I've got. And as I approached this evening, I began to wonder what exactly would be expected. There aren't any precedents to go on. And I suppose that's one advantage for me, because nobody, whatever you feel, can say, well, it wasn't as good as last year. So, the public engagement of science, there is a lot of it going on at the moment, and I can't even begin to think about the number of enterprises which are going on within our own Beltane, which the President's mentioned. So I had some diffidence as to what I should try to cover. And I felt one thing, that at least I should give you some example of some of the work which I've done in engagement, and I will do that. But I do want to extend beyond that. Hence this rather pretentious title. I think it should really be communicating science as part of culture. That's really it. Because I am going to stray outside my own strict field, and Indeed, I don't think I'm going to say anything very profound. It may be rather obvious to you, at least parts of it may be. But my experience is that much of the public engagement of scientists with, much of the engagement of scientists with the public doesn't quite catch the full nature of what it's like to do science. Science as a process, something that you're engaged with yourself, not just what you have discovered and can bring forward. And that's really what I mean by bringing culture, bringing science into the whole practice of culture. Now, the reason I used that term was really because I was pretty furious. At the time when the Scottish Parliament was formed, there was a whole lot of guff came out, many flossy pamphlets about the cultural strategy for Scotland, and pamphlets which were giving guidance for local authorities and so on. Here's the definition of culture there, cultural strategy, and you'll see it's got everything there, Uncle Tom Cobley and all. But I went through this flossy booklet. It was pretty turgid stuff, so I can't be sure that I got it right. But I did not see a single occurrence of the word science anywhere from start to finish. I thought that was pretty awful, and I've pondered about that ever since. And one of the results of that pondering is what I want to talk about tonight. Now, I think this lecture will be something of a potpourri, because it's got some stories, some pictures, some bits of film, some book suggestions, and possibly even some quotations. Well, certainly some quotations. But first, I did say I would give you some examples of what I have done. And of course, my subject is animal behavior. That's been my branch of zoology. And there, one is very, very lucky at the outset, because it's a subject which is inherently, immediately attractive to everybody from nursery school to U3A, University of the Third Age. And you don't have any trouble at all in getting an audience's attention. Well, let me show you one delicious kind of example. Here is nobody I've ever shown this to has failed to laugh. This is an elephant in one of the Russian zoos. On its own, it's just delighting in this waterfall. And of course, what appeals to us immediately, part of animal behavior, is that the elephant looks amazingly happy. And the reason it looks so happy is that it's smiling, you see. And that's where a superficial, quick look at animal behavior can lead you into some misapprehensions. The elephant is, I'm pretty sure, feeling good. There are probably, we could measure endorphins going round its cerebral cortex and so on. But it's not smiling. That's just the way its mouth is formed. So we begin to empathize straight away on superficial characteristics. So the downside of trying to engage people with animal behavior is that they come thinking they know a lot about it already. But then, of course, you can go further. Animals playing, again, here a very familiar scene. But if we begin to think about this situation, it contains elements, indications of something rather profound. These two dogs are playing, and as you know, they will go on doing this, perhaps for half an hour on end. Now, this dog weighs about twice what that dog does. So it can easily just jerk and pull the other dog over. Or if they chase one another, this dog could catch the other one up very quickly. But they don't. The big animal self-handicaps itself because it wants the game to continue. And that, I think, immediately begins to suggest that there's something rather sophisticated about the way in which these dogs play. I'm sure you will have experienced this yourself. You can play a go-fetch game with a dog, and it will quite quickly understand that if the game is to go on, the ball must be dropped close to your feet where you can reach it. It's no good the dog dropping it over there. You then say that and it will bring it up. So here's an example where our empathy with animals can actually lead us further on. And the cognitive abilities of animals, the idea of animal minds, is a very hot and highly conflictual area of animal behavior. So that's just my field, if you like. And now we go outside it. Now, surely all of us who have been involved in it with the public, in the engagement with our science, know that it's tremendously enjoyable for the scientists. And for the public also, I think there's a great, much more interest and requirement for some joined-up science than is often taken, the public are given credit for, certainly by the media. And the subject is taken very seriously now by scientific establishments. There are chairs of public engagement endowed. We have vice principals who are involved in engagement. It's very much part of one's duty, part of one's contractual obligation to undertake this. And I think it's worth remembering that this wasn't always the case. I wonder if this face brings back certain memories. Magnus Pike. In the 1970s, he was on television on an almost daily basis, and he became really one of the very first of this awful category now, which is certainly overfilled, celebrity. At the time of Magnus Pike's programs, if you asked the general public to name a scientist, there were three that came way out, way above all the others. Newton, Einstein, and Magnus Pike. That was the case. And a second person, David Bellamy, involved in a whole tranche of television, of popular science, with a very strong conservation angle in Bellamy's case. Now, both these people, and particularly Magnus Pike, got a great deal of stick from this. Magnus Pike was attacked, sometimes quite viciously, by fellow scientists. He had been the chief scientist of the Distillers Company, and he knew he was a chemist, a biochemist, I think, in origin. But he was said that he was demeaning his subject and dumbing it down, and that this was reprehensible in some way. So let's quote you from a very nice obituary of Magnus Pike, who was a very nice man. I had the good luck to do some early television work with him. He was a splendid man, and Simon Welfare's obituary of him says, "He showed a passionate love of the fundamental principles of science, a belief that no subject was so obscure that it could not be explained, and a wish to share with the world the enjoyment of weird names, theories, and arcane historical facts. Pike really did have a mission to explain, and he carried it out with a cunning deployment of wit and humour." That catches him, I think, very well, and one salutes him, and I continue to salute David Bellamy for what they've done. They certainly made science popular, and in doing so, they brought out some of the beauty of the subject, and the beauty of the natural world came through. And that, I think, is such an important part of the engagement we want to take part in. And, of course, since then, there have been many others who've carried this on, as far as my own subject, biology, goes, orders of magnitude further on. I just mentioned the name David Attenborough and need say no more. Now, one advantage I have personally, as I see it anyway, is that I am a bit of a nerd myself. I do love arcane facts for their own sake. And my first love in science, when I was at school actually, was inorganic chemistry. And I was absolutely delighted to discover recently that Oliver Sacks, the psychiatrist who wrote those wonderful books, Awakening and The Man Who Mistook His Wife for a Hat, he also fell in love with inorganic chemistry. And a wonderful book which he wrote. That is my love of facts. I just love showing this to an audience whenever there can be an excuse to do so. I think it is just a wonderful thing to contemplate. And it's not just that I want to cut humanity down to size, but I do think this is bound to give us some thought as to our place in the universe. It is extraordinary. I've turned over 2 pages, that's why I missed out. Okay. Yes, 2 books that I would recommend straight away. My Uncle Tungsten. The title is because his uncle was the man who developed tungsten filaments for incandescent lamps, which was a gigantic advance because all the other lamps burnt out in 10 minutes. But he had access to a big chemical factory, and he used to give samples of really quite rare and difficult elements to young Oliver. So he had a chemistry set which certainly outweighed mine. On one occasion he describes how his uncle gave him in a jar of paraffin a lump of metallic sodium about the size of a fist. And he and a friend took it along to a bridge over the Serpentine and dropped it into the water. Much fizzing and orange light there would have been. Well, anyway, I do recommend Emsley's book. It's absolutely wonderful, and it stays near the chair in my study, and when I'm fed up with what I have to do, I read delicious facts about protactinium and krypton and cobalt and so on. Okay, well, my own happy experience in public engagement was my great good fortune in being picked up by the BBC to present some Earth Story, which was called a landmark series at that time. And it was 8 50-minute programs about the history of the Earth and the modern approach to the history of the Earth, which was still had a wonderful feeling of newness about it, plate tectonics and all the implications of that. Well, it was absolutely wonderful experience for me because it introduced me to earth scientists. I went into the field with earth scientists and got to peruse the landscape in a way that they saw it. I might be looking at the insects and arachnids poking around on the edge of the rock face, but they were reading the rock face in different ways. And it was a quite wonderful experience for me. One of the most compelling, charismatic geologist I met was Martin Dewitt, a South African, and he is working in the Barberton mountain range, which is in the eastern side of South Africa, just north of Swaziland and on the edge of the Kruger Park. It's a wonderful, huge area of very ancient rocks, 3.6 billion years old, and very, very unmodified, unmetamorphosed, as I think the geologists would say. It sits there as a kind of time slice of the archaic Earth, which was still a very young planet at that time. And a lot of the Barberton rock was erupted under the sea, because you can see fossil pillow lavas. You can imagine when lava erupts underwater, it instantly is cooled, and great mountains, like great lumps of toothpaste, begin to accumulate around the fissure. Martin found plenty of those, but he also found one other wonderful thing, and I hope this is him showing it. Here he is. In the Barberton. The combination of volcanic activity and water produced an environment where a fascinating new process could begin.
I caught these structures by accident.
And when I looked at them, I thought, what is
that? You know, I didn't have a clue what it was. I'd never seen anything like this before. That same year, I went on a conference to New Zealand. And during that conference, I had a chance to sit around some of the mud pools in New Zealand. And while I was looking at this bubbling mud, I all of a sudden remembered these structures. And wow, that's it. That's got to be what it is. Ancient mud pool structures, frozen in the rock here. And what gives it away as a mud pool is, of course, all these intersections. What is even more interesting to think about is the warmth of this area and the sort of niche it might have created for bacteria, for example, to be swimming around. And this is, of course, one of the sites we might be thinking about where life might have started.
Now, I think that's just a magic discovery, and it must have been a eureka moment, I think, for Martin Dewitt. And it's so wonderful to be able to read the rock and to know that there were mud pools. In other words, this part of the Barberton was above the sea level 3,600 million years ago. It was a wonderful moment, and it leads me on from this to think of science as really expounding a particular kind of beauty, which is exactly equivalent to a poem or a piece of music. Now, of course, I want to talk about science as part of culture, and culture is a personal construct. But I do think that you will all have similar examples, and I would just see that we should be communicating the creative aspects of science, the fact that science is creativity, and it involves the intellect and the emotions, just as does any other form of human activity. And why is it necessary to say all this? It may be very obvious to many of you. I hope it is. But the fact is that C.P. Snow's Two Cultures, Liam Hudson's Contrary Imaginations, it's still around, those thoughts that scientists are different sorts of people. And that they are exploring the world and feeling in a different way from others. This is one of my heroes, if you like, a person I greatly admire. Bronowski, you will remember there was a landmark series for you, The Ascent of Man. That was the first really big, major television series by BBC when colour television came in. It was a wonderful thing. Bronowski, he came over to Britain. He was born in Poland at the age of 12, and he claims that he could speak virtually no English at all at that time. But this is what we should be trying to get into our education system. And read Richard Holmes' wonderful book, The Age of Wonder, about 18th century science, 18th century society, in which the distinctions were not, of course, nearly so clear-cut. I mean, it's obvious why, because professional science didn't really exist at that time. But there in the stories of Herschel and Montgolfier and Joseph Banks, there is a wonderful story. Now, as I say, I think those divisions still persist, because we still, in schools, effectively force our young people to choose between arts and science by about the age of 12, 13, 14. And there we have set up these two categories, the nerdy scientist and the free spirit of the artist. And the media, for the most part, don't dissent from this. It's around. And I don't know whether you are like me, but when items of new science, some discovery comes on the television news, what you would like, of course, is to have the exposition of the person speaking about the science. If it has to be the newsreader, so be it. But of course, television can't do that because the media are terrified of talking heads. So what we have stuck in the background is this, something like this. I mean, you will have seen it. For me, I don't know whether Gilson pipettes, the people who manufacture them, have got some talk about product placement. I mean, Gilson pipettes appear, and whether they're relevant, whether what the person is doing is relevant to the actual discovery seems unimportant. What this does is to fill up the tyranny of the picture. The screen has to have something in it whilst the words are being put across. Now, of course, the scientific method does indeed impose a certain kind of well-delineated structure on the way in which we operate. And the media take this on board and expect us to know the answer straight away. Scientific tests have shown that. That's a phrase which I really hate. Is it safe to eat beef now? You know, and the chap at the BSE thing saying, well, we know. No, what they want to know, can I eat beef? The idea of a probability, of a judgment is very, very difficult. And that, I think, is one of the things that good engagement with the public, its most important outcome, to help people to be better judges and to recognize the clear distinction between an opinion which is based on evidence and a belief. They're mixed very badly at times. Bronowski again. And scientists, of course, try to come up with hypotheses that stand the test of time, but they must be ready to put them down. And the practice of science is not always that cold seeking after knowledge that might be implied by some people. Opinions may quite imperceptibly elide into beliefs. And here's my story, one story. Peter Mitchell, Nobel laureate in 1982, I think, a colleague of mine in the zoology department when I was a young pipsqueak, a delightful man. He was not only brilliant, he was extremely rich because he came from the family of Wimpy, the construction people. And when he got fed up with university life, he went and built himself a laboratory in Cornwall. And that's where a lot more of his work was done. But the pioneer work on the chemiosmotic theory of energy flow in cells was begun in Edinburgh, up there at King's Buildings. We have a little brass plaque on the door where that work took place. The Biochemical Society, in their wisdom, and I really mean that genuine, it's not sarcastic, have videotaped, got film of a number of distinguished biochemists. And they have a lovely film of Peter Mitchell in discussion with his lifelong research assistant's not a strong enough word, research associate and right-hand person, Jennifer Moyle. And in it, they're discussing how difficult it was to get the chemiosmotic theory accepted. People were searching for various energy stores in cells, in molecules, and so on, and trying to put this was the main accepted hypothesis. And then Mitchell and Moyle came up with these various suggestions that, in fact, a chemiosmosis was going on across the membranes, which depended on electron charges. I can't give you the meaning and verse of that. And gradually people began to take notice. And more people began to test the chemiosmotic idea and finding that it fitted. And it began to, what began as a trickle became a swell. And eventually a huge majority of British scientists had come to this conclusion and supported Mitchell and Moyle. But there was one group, I think in King's College London, which rather held out. And so Peter describes, well, we thought the best thing to do was to ask this person down to do some experiments with us here. And Jennifer said, well, she came, didn't she? And we convinced her when she'd been here a week and we did the experiments, and I remember her saying to me, well, I think that shows that the chemiosmotic theory must be correct. Peter said, yes, well, that was my understanding too. Jennifer says, yes, but then she went back to King's, didn't she, and did another experiment or two which was entirely rejected and went back on the old theory. And Peter said, well, that's not very surprising, is it? Scientists aren't the most rational people. I've always remembered that. And I had the great privilege to meet and talk to one of the great innovators who had real trouble getting an idea across. This is Mary Tharp, an American geologist working on survey ships during the 1960s, the height of the Cold War. The US Navy wanted to know what the bottom of the oceans was like, because they would have to engage with the Russian Navy down there, you see. And so they were financing sonar surveys. The Lamont Doherty lab, where Mary Tharp worked, its director didn't believe in Wegener's continental drift. And he discouraged very strongly any of his staff from working in that area. But of course, he financed the US Navy was financing these ships. And so Mary Tharp went out, and they were surveying the bottom of the oceans.
Ships sent out pulses of sound.
This will remind you of any destroyers versus submarines movie you've seen. That's Richard Widmark in the destroyer.
The time taken for each ping to make the journey gave the depth of the water at that point.
We've basically been using the same types of precision depth recorders since the end of the Second World War. As you can see on this record from the 1950s, basically you can see that the bottom is a very fine trace here, very strong fine trace. But there are also places where the echo sounder record gets very, very confused, and in those areas you have to be very careful to interpret them correctly.
Two of the first people.
There's the young Mary Tharp.
Bruce Hazen and his colleague Mary Tharp. They became experts at making maps from the echo sounder data. Their maps at last began to reveal what the bottom of the ocean looked like. However, their task was far from easy. The oceans are huge, and the ship's tracks were few and far between.
Yes.
Mary Tharp is retired now, but we met at her home near New York, where she used to work on the data.
We made this map using that data.
There's an amazing amount of detail here. How did you extract it from just those tracks? How did you do that?
Well, where we had a track, we took it very seriously and exactly, but then it'd be so far to the next track that we had to do a bit of inspired guessing to fill in the space.
Right.
Actually, in this area, we didn't have any data at all, so that's why we put the legend there.
Piecing together the echo soundings revealed the existence of a vast mountain chain running down the centre of the ocean. As more data became available, Hazen and Tharp traced this ridge throughout the main oceans of the world. It ran on and on, snaking around the entire globe for 60,000 kilometres.
It's an extraordinary discovery. I mean, what was the world's reaction to that?
At first, it was one of amazement, and then skeptical, very skeptical, and finally extremely scornful. And it was, you know, it was hard to convince them. It was a shocking thing to say.
Marie also noticed something odd about the crest of the ridge, a feature which looked suspiciously like evidence for Wegener's unfashionable ideas.
Here is the Mid-Atlantic Ridge, and the unusual feature is it has this great big cleft in the middle of it. There is one there, and here's a cleft in the middle here, and here's a cleft in the middle here.
So what did you deduce from these profiles?
Well, I showed it to my boss, Bruce Hazen, and I had plotted the position of this rift valley along the center of the ocean where it occurs, and he just groaned and groaned and says, this can't be. It looks just like continental drift.
Why does that mean continental drift?
Partly because you could spot it was a big rift valley, a big cleft in a mountain range. That's quite a large valley inside of a huge ridge. And it looked like a chasm that would be naturally the feature it formed if the continents were pulled apart.
Well, I think she was 84 at this time. She's dead now. And to say she was a lively person is an understatement. I loved her blue fingernails. But look, the problem she had, people were scornful. Isn't it extraordinary to think that? So we move on, probing, testing well-worn hypotheses, seeing if they put up with that and can stand being retested. But I always feel we should keep a pretty close and fairly generous look at our heretics, because some heretics will be tomorrow's establishment, and they're not all. Being challenged is an excellent thing. I always remember Carl von Frisch when he first enunciated the extraordinary story of the bee orientation dance, in which they can communicate the distance and direction of food sources, saying that no competent scientist should believe this without having retested it for themselves. Well, this is a very human thing. The mindset, the reluctance to accept new facts, even pouring scorn on people who have made astonishing discoveries. In my view, the discovery made by Mary Tharp, in terms of what it told us about our planet, it's on a par with Galileo first describing the moons of Jupiter. She was a very unsung person. She'd never been filmed in this way before. She'd been long retired, and the ideas were already 30 years old, more. But the Japanese were coming to film her next week, but nobody from the USA was going to film her. Well, too late now, but we've got her on film. Now, another very human feature of our science, and which is worth not withholding from the public, is the whole idea of competitiveness and vanity, which is so much involved in a lot of scientific research. Here's Francis Crick reviewing the film, this film here. If you've not seen it, I don't know whether it's still available. It was a simply splendid film. They were, Crick and Watson, I remember in Watson's book, The Double Helix, describing how when they learnt from the States that Linus Pauling, who was really going hell for leather to try and break DNA as well, had gone down a wrong path. They were quite certain of it. They went down the pub and celebrated. They were celebrating. That's scorn of another kind, of course. I mean, Linus Pauling is no fool. Anyway, I think the film has some wonderful things in it. One of the most splendid moments is when they've got the first model of the double helix, and it's gone down to Maurice Wilkins' lab in London, and there is Rosie Franklin, a woman whose superb X-ray crystallography had first really made possible because it gave the clue that this was DNA was a spiral structure, and Crick describes how at this time they still weren't sure that they got it right. They thought that maybe they'd gone out on a limb and would be proved to be completely wrong. But in the film, Rosie Franklin is shown this model, and she's asked, "What do you think about it? Do you believe it?" Oh, yes, she says. "Why do you believe it?" "Because it's so beautiful." That's a very moving moment in the film. And Crick says that the actress, it was Juliet Stevenson, who played Rosie Franklin, played her extremely well, just as he remembered her. So, I want to begin to wind up with another example of a piece of science which, for me, has got all the qualities of creativity. Just the thing we want to convey about the way science operates in our society, the way it's part of our culture. And this comes from mathematics. And I look on mathematics as a kind of beautiful landscape. I am viewing it from an edge, And I know I'm never going into that landscape, but it still looks beautiful to me. I had the great good fortune to have a wonderful mathematics teacher at school who just enabled me to glimpse into the beauty of mathematics. And I've always loved reading about it and about reading about mathematicians who are a rather extraordinary set of human beings. I'm sure you would agree. And to me, it makes quite clear that Magnus Pike was right. It doesn't matter what science you're dealing with, it is possible to explain it at a level which will give you a hint of its excitement. I have no possible way of going into, I can't even understand the titles of papers in mathematics, but if it's explained to me properly, I can get a hint of its magic. Well, of course, it has to be this, doesn't it? You all know that the reason it's this is that what is so wonderful about Fermat's last theorem, I believe it should have been properly called Fermat's conjecture at that time, is that we all understand it immediately. We all know x squared plus y squared equals z squared from our Pythagoras at school. And we are told that Fermat wrote this in that he had a proof in the margin of his diagram. And if you've not read it, there's another book recommendation. That is a super book, because it goes right back to the Greeks and number theory. And whole numbers. Numbers are the most magical mathematics for a non-mathematician, I think. I mean, we all know them and love them. There are still wonderful problems about numbers. How are the prime numbers distributed and so on? And then this conjecture that all even numbers can be expressed as the sum of two primes. That sounds very easy, doesn't it? I mean, 6 is 3 plus 3, and 12 is 9 plus 3. And no, that's wrong. 9's not a prime. Never mind. But apparently that has been proven up to an even number which has 136,000 digits in it. But of course, for mathematicians, I haven't even started. I mean, 136,000, where is that? That's nowhere. So it still remains to be proven. Well, the story of this, of course, is dramatic and very, very compelling. The great mathematician, Andrew Wiles, first came to Fermat's conjecture when he was about the age of 10 and became fascinated by it ever thereafter. And as you know the story, he began to work on it. And it's really rather remarkable, the nature of that story, because what happened was that he was in Princeton and he began to work rather secretly on it. He thought he had the beginnings of a new attack, which came from the work of these two brilliant Japanese mathematicians. The Taniyama-Shimura conjecture, which was about modularity of functions. I don't know that functions are modular, and this linked up in some way with the elliptical equations, which Wiles was working on. But look, I have no idea what that means, but that doesn't matter. When you read Singh's book, you will get in to the way in which these mathematicians were working gradually towards it. And in the end, Wiles came up with a proof, and he at last confided in one of his fellow mathematicians at Princeton, Nick Katz. And because he didn't want, there was mountains of material for Katz to go through and check. This is what mathematicians do to check out a proof. And they thought the only way to do it was for Wiles to give a series of lectures to the graduate students, which were ostensibly about this particular branch of mathematics. Katz would be in the audience. And as Wiles went on, 8 lectures, gradually Katz would be able to check as he went along the nature of the proof. Well, what Wiles did first was to prove the Taniyama-Shimura conjecture. Shimura's still alive and in Princeton, I believe. Taniyama, that's interesting. He killed himself at 31. And Shimura, in the film, if you get to see the film made by Simon Singh, very movingly describes his feelings when his colleague and young friend died, killed himself. The reason was very strange, but I've been dipping into, second-hand only, the mathematician Alfred Adler, who says that almost all great mathematics is done by young people. By the time you're 30, there's not much more. This is Adler's view. He's a pretty arrogant man. I'll give you a quote from him in a minute. But it is quite remarkable. Taniyama left a note in which he said he felt that his best work was behind him and he could not see a way forward. What Adler says about mathematicians shows no trace of reluctance to expound elitism. Each generation has a few great mathematicians, and mathematics would not even notice the absence of the others. They're useful as teachers, and their research harms no one, but it's of no importance at all. A mathematician is great, or he's nothing. Well, reading that made me quite glad that my field was biology. However, Adler would understand, I think, why Taniyama killed himself. Anyway, Wiles got as far as these lectures and the proof, and there was cats discovered a flaw. And I wouldn't say collapse of start party, but Wiles was absolutely shattered by this. And he had to go back and go back and go back. And eventually he got it. There's a eureka moment for you, if you like. An extraordinary thing. Anyway, it's been done, and it's a wonderful, beautiful story. And I think it's certainly something that people could put across in a secondary school. No problem at all. So our science communication will be more valuable if it expresses something about our motivation and the whole process of how we get there. Recognise that delight and beauty, enjoyment in what you're doing, can go with the evidence. It isn't against the evidence, it can go with it. And we don't have to banish emotion and creativity. Well, we certainly don't have to banish creativity. We don't have to banish our feelings if we're going to do good science. Now, I want to close with a final quote from a fellow biologist, Daniel Lehrman, who died in 1972. He was a wonderful person. He had a great influence on me personally, on my career. He worked in animal behavior, but he was a polymathic person. And what he said is so much exactly what I feel. There is another aspect of the activity and life of a scientist, and another function for science, which is not often enough stressed. In addition to, or instead of, serving a function like that of an engineer, the scientist can also serve a function like that of an artist, or a painter, or poet. That is, he sees things in a way that no one has seen them before, and finds a way to describe what he's seen so that other people can see it in the same way. This functioning is that of widening and enriching the content of human consciousness and of increasing the depth of the contact that human beings, scientists and non-scientists as well, can have with the world around them. Now, I don't think there's anything much more important than that, because at bottom, most of the issues and problems which face us are because we do not see ourselves properly sitting within the world around us, both the social world or the world of our fellow living creatures or the world of our planet. A last word from Bronowski. I think we'd all agree with that, and that is the joy of being a scientist. But I love this statement. Being an intellectual doesn't mean knowing about intellectual issues, it means taking pleasure in them. And it's that pleasure that I think is such an important part for those of us who are scientists, to express when we engage with the public. So my thanks for the honour of the Beltane Award, and I hope that my feelings of gratitude shine through, and my pleasure in science. Thank you.
Well, I'm sure that everyone enjoyed that. It's a really remarkable insight into the beauty of science. And I just jotted down some of the descriptors here that Aubrey has used. And you could be we could be having a seminar about poetry. The happy elephant, the enjoyment of Magnus Pike, the sheer enjoyment in his work. Rosie Franklin, because it is so beautiful. The structure is right, it must be right, it's appropriate because it is so beautiful. The hint of magic in what you've done. The indescribably beautiful structures that we've seen. These are some of the phrases that you use which indicate the excitement and the beauty of what scientists see. And I had one such moment, which I'll just share with you very briefly. In the late 1960s, I was in New York University Medical School, and we were working on a collaboration there with, I was working on a collaboration with an electron microscopist. Now, I'd been looking at the effects of a toxin which affected cell membranes. This is a long time ago. And we couldn't work out how this toxin worked. And John Fear, who was the electron microscopist, said, well, look, you give me some toxin, let's sit down, we'll make some red cell membranes, we'll look at them under the electron microscope and see if we see anything. So we mixed the toxin with the red cell membranes and we looked in the microscope, and what we saw was indescribably beautiful. Because how the toxin worked was it polymerized, it formed little hexagonal rings in a beautiful array across the membrane, and that actually, after a little bit more work, described how the thing worked. But it was indescribably beautiful. So it's over to the audience now to raise any questions you would like to do. We've got microphones. Would you please hold the microphone close to your mouth so that we can hear, and ask your question, say who you are, and Aubrey will answer. We've got a question from, who would like to start? Second row back, yes.
Neil Mitchison, currently of the European Commission. Aubrey, I think I want to throw one extra point in. You described sometimes the beauty of science. You described how some things, you say, are so beautiful they have to be right, even if sometimes they didn't turn out to be wrong. But there's an even trickier one, I think, sometimes, which is, and I'm thinking of things like, for example, relativity, the Minkowski space-time analysis of relativity, where people say, hey, you had that nice way of looking at the world, and I'm now going to show you it was wrong, and why it was a reasonable approximation in the past. It won't do for the future. You're going to need something new, that science can shake us, as well as giving us blinding insights. It can say, hey, you were quite wrong.
I think all I want to do is to agree with you. That's absolutely the case, isn't it? And of course, we evolved. The Newtonian world, universe, fits so well with our experience, our life here, the length of time we live and the observations we make. It fits wonderfully well. And it does. What's mind shaking? What is it? Earth and its some beauties lay enwrapped in night, God said, let Newton be, and all was light, but not for long. The devil shouting, ho, let Einstein be, restored the status quo. Yes, that was absolutely it. And of course, it is very difficult, isn't it? I personally, I've said that I felt that no science was impossible to put across, quoting Magnus Pike. Lewis Wolpert, a developmental biologist, has argued that there are some branches of science, some aspects of science, some findings, which are impossible to put across in simple ways. And of course, that may be the case if you really require advanced mathematics in order to get to square one. One of my problems is with quantum mechanics, and so I do try to read one book a year, I suppose, which is trying to put this across. And I get on okay at the beginning, and then we get on to string theory, and I cannot get my head around it. Yeah. It is extraordinarily difficult. But in a sense, the struggle is inspiring.
Yes. Question down here, third row back.
Catherine Smith, I believe I'm continuing on that same theme. We have an issue with understanding at a very basic level, I suspect, which goes back, take the example that we used to call physics, as we call it today, natural philosophy, and indeed when I was at Glasgow University they still called it that, and I was fortunate enough, even so late as going through in 1967 to 71, to have one professor who made sure that I, if not the rest of my class, got that feeling that what I was studying included the whole philosophy of life, the universe, everything. But how many universities have forgotten that once upon a time natural philosophy was what we called what is now very matter-of-factly and very unemotively, unemotionally called physics? And is it possible that Einstein did indeed do us a great disservice in that he went where the philosophers of the humanities could not follow because they could not any longer understand his maths?
It's a bit, I think there has been that divergence, I agree, but it's a bit hard on Einstein. I mean, what else could he do, really? If we're to explain, we have to go there. As we know, Einstein couldn't get the whole way. He was a very frustrated man himself, and I'm never quite sure. He made a number of almost sort of playful statements about the philosophy, and also hinting at supernatural powers and that sort of thing, which Stephen Hawking also does. Who was was it Hawking? Does God play dice? I think that it was Einstein. Well, there we are, grappling with it. But I agree with you. But perhaps what's behind your feeling, which I certainly share, is a great pity that there's so much now that it's very impossible to have people like Joseph Banks or Herschel or Darwin even to get there, because the polymath has a huge job now. I mean, it's just so difficult. But I rather cherish that name, natural philosophy, just as I cherished and was particularly glad that when I got a chair in this university, it was the chair of natural history. I mean, it was almost set against natural philosophy, of course. And nobody calls chairs natural history now, I fear. Well, I suppose mine still goes on. It becomes zoology, and then zoology begins to break up. You have genetics, developmental biology, immunology. All of these are separate honours schools now.
Next question. Yes, the middle here.
Good evening. My name is Barbara Monroe. I have the honour of being one of your students at Edinburgh University many years ago. My question is, or point I'd like to raise for discussion is this. In today's world, there is an awful lot of modern investigation, research into stem cell and other forms of science like this, which directly affects the general population. And I think we need to raise the debate of this kind of research and provide support to the scientists rather than, let's say, antagonism in these things. How do you think that we can get over the communication about this kind of research, which is really quite complex? There are quite often articles in Metro, for example, about this kind of thing. It's a wee paragraph. Thank you.
Well, it's way outside my field, of course. Although I would have very strong opinions on it. I mean, the trouble here is that one has to say that one is on the interplay with attitudes, some religious attitudes, some attitudes of prejudice against any idea that human beings can be typecast or cloned or shaped in some way, that it's not you can have a designer baby and so on, is a thought which is repellent to many people. How can we best help? I mean, I would go back to the, in discussion, to be as unthreatening as possible and to point out that there are differences between evidence-based opinions and beliefs. Science can't deal with beliefs. If you want to believe something, all I can do is to show you evidence that makes that belief a bit more difficult to hold, but that may put up the barriers and go on. I'm not quite clear where the main problems with stem cell research come from, because I suppose we're looking for more and more ways, and I believe it's getting possible, isn't it, to clone stem cells from umbilical cord and things like that, which ought to be fairly unthreatening from a religious point of view, I would have thought, if you believe that, the human fetus is special. But what else can we do? I mean, it's all part of the flight from rationality, which I find really rather terrifying. And many biologists, of course, have great trouble with the what's called the Animal Liberation Front, with which, or that group of organizations. I think it's absolutely essential that scientific research on animals is regulated, and it's regulated up to the hilt in Britain. And the demand for regulation came from the scientists themselves. But there again, we do need to defend good science, and I think I'm really just floundering around. I see no way to do this other than to keep banging away on how science ought to be, good science ought to be liberating, give us more choices in the future.
Question at the back, second row from the back.
Hello, I'm Charlotte Kirby and I teach in secondary school in St Andrews. Just like to say thank you very much for that very clear talk. And just in relation to the stem cell issue, I'd just like to say how much the modern curriculum is addressing, educating our children about such issues and about using animals in experimentation. So there is very much going on at the school level, all of these sorts of things. We also teach the IB in our school, and the theory of knowledge aspect of that curriculum is a wonderful way of introducing children to philosophy and the interactions between subjects and the ways that science is beautiful and comparing it to the arts. So there is a lot going on within schools to address many of these issues, and thank you very much for your talk. Our pupils would appreciate your talk.
Well, excellent. That's great news.
Yes, question at the aisle here.
Aubrey, I enjoyed your talk immensely. I came up here at the end of the 1970s to start up a thing called the Open University. People may have heard of it. I was responsible for the whole of science for the whole of Scotland for 22 years. It was an incredible thing to do. Now, what has come to light this year is with regard to a remarkable man, Arthur Holmes. And I think if I were to ask people generally if they have ever heard of Arthur Holmes, most people would say they'd never heard of him. This year is the centenary of Arthur Holmes beginning his work dating the age of the Earth. A remarkable achievement. In Britain, he was a fellow of both the Royal Society of London and this society. In Britain, we're doing nothing, apparently, to honour Arthur Holmes, but on Sunday afternoon, October 9th, in Minneapolis, they had a whole afternoon honouring Arthur Holmes and his work. Now, what has come to light this summer, incredible as it may seem, is what Arthur Holmes did as early as 1929. That's really very early. He was Professor of Geology at Durham before he came to Edinburgh, to the Regis Chair in 43, retired in 56. But at Durham, he went up the road, or possibly on the train, to Newcastle. And he broadcast 9 lessons in geology on a Friday afternoon, each lesson half an hour, from late April to late June in 1929. Now, the BBC was only set up in 1922, and from an early date in its history, the BBC made a big effort to broadcast to schools. And so I think it's a wonderful example of this great man, mostly unknown now, even unknown to people like Sir David Attenborough. We're living in an age, forgive me, President, saying this, but we're living in an age of celebrity bullshit. Arthur Holmes was an extraordinary man who, despite all the work he was doing as a scientist, nevertheless, he was prepared to find time to communicate science to schools as early as 1929. Thank you, President.
Just in front of you is another question.
John Francis, well known to Aubrey. Congratulations on your sustained effort over so many years to communicate science. But there's still, of course, in the general population, an apprehension. I began my scientific career as a nuclear scientist, and there's a phrase that has been used about nuclear science in particular, that what we have done with nature is to strike a Faustian bargain. Do you think, with your accumulated wisdom and experience, that there are certain kinds of science that have become a Pandora's box, and therefore we need to tread increasingly carefully?
Well, how you put it absolutely right. I mean, the Pandora's box image is very strong there. And if I can start on nuclear power, I feel the situation we've got ourselves into is such that we have no alternative but to go all out for nuclear power to get us through the hump of energy supply. In other words, I agree with Lovelock, James Lovelock. Whereas I certainly didn't. I remember going and standing on the beach at Torness with a megaphone shouting about the iniquities of Torness. However, your further point is much more interesting. And are there certain sorts of science that I find menacing? And I think probably I do find the matter of trying to, I suppose, eugenics in its modern aspect, trying to breed superior types of human being. Of course, eugenics has got a terrible name because it's mostly negative eugenics. These images of Hitler sterilizing the mentally defective and gypsies, and of course another group of people whom he thought were defective. But it's not, and that's not so much there now, but it's the idea that we could, begin to select for and examine eggs and so on for this. Very interesting. I don't know whether you saw any of you when it would have been, I suppose, 60 years since the Double Helix or something. Jim Watson was going around on touring here, and he was arguing quite strongly for now we've got the human genome sorted out, we should begin trying to identify those genes for intelligence and cloning them and putting them into people. And he said, I know everybody's putting up hands in horror, and there was somebody else on the panel who was putting a hand up in horror. He said, that's all really well, you're very intelligent. But if you were a dim person, you wouldn't mind having some intelligence injected into you. I mean, you know, and he had a certain sort of crude point there, and I suppose I would feel how many of you feel. I would feel that if we can screen against some of the really bad genetic defects, which will lead to great distress and suffering in life, I really do feel that we should not allow them to go forward. I mean, there are so many fully fledged human beings who are getting no kind of chance on the planet at the moment because they're not getting enough to eat. That's the basic one. That for Western rich medicine to keep alive, you know, babies born at some desperate prematurity, for instance, so that they are as we know, I know from my wife that the future mental life of these people is threatened. That I think is repugnant. But it is an extremely difficult one, isn't it? But I would say that the eugenics aspect was the thing that worried me most about science, about the potential for medical science.
In the centre, just towards the back, there are two hands up there.
Hello, I won't give myself a full introduction as I'm what's generally known as a member of the general public, someone with an interest in science, but with no great formal background. I think one of the defining themes of the age that we live in is the variety of sources of information that people have at their disposal and use to take in the world and to view the world. To what extent do you think this is an opportunity, and to what extent do you think this has caused some problems? I particularly think of finding there was always this concept that with the internet people would be exposed to a whole world of new ideas, and someone popped up a couple of years ago and said, actually people are just listening to people they're agreeing with, but they can listen to a lot more of them. So to what extent do you think this great diversity of information presents opportunities, and to what extent is that possibly walling people within a wall of ignorance?
We ask you a question while Aubrey thinks about that, which is, what's your take, what's your impression of the scientific world now? You introduce yourself as somebody who is a generalist, but obviously with an interest in science. Could you tell us a little more about what your appreciation of it, of how it's presented, what you think of it, how it's presented in the media?
I think there are a lot of problems with the way it's presented in the media. I don't think there's any bias there. I don't think there's any conscious intent on the part of the media to misrepresent science. But I think the media, because it's a corporate thing, it's not an individual. It's a group of individuals behaving as a group of individuals do. And I think as a result, it has a bias towards simplicity. It has a bias towards things which are absolute, which are black or white, and as such it has a slight phobia of anything which is grey and anything which comes with too many contraindications, too many PSs at the bottom. So I think that will be problematic. I think there's some people who are doing a really good job, but I think there's whole areas of discourse where scientists are not getting involved and are saying, well, these people are clearly crazy, so there's no point in talking to them. And I think there is a problem that you're potentially creating. There's areas out there where, because it is a tough fight and because you will get shot down, you will encounter people that seem very irrational, the debate just stops,
Right.
and you
Well,
get a polarisation there.
I think this is a fairly important issue, actually. Is science becoming too threatening, too challenging, too difficult to explain? I mean, there is. It's not terribly well done over the piece.
I mean, I really agree strongly with your the way you describe the media. I mean, what has always worried me is I've hinted at it here that they want black and white answers, and that's why I emphasised and said more than once, I think, one of the great benefits which knowing some science and knowing some philosophy can bestow is making you a better judge. And my goodness me, the public needs to be helped to this, because the judgments we're required to make all the time are simply awful, and there are polarizations in every field. I mean, in the field of economics at the moment, I mean, how can one sit back and see the spend now, expand later, and contract now and expand later? Those two schools going at one another the whole time. I think I'm not convinced that science is becoming too difficult. I still believe very largely. I mean, with the possible exception of certain mathematical ideas, I still think it is possible to get across the basic principles as to what people are trying to do, and even to ask the public to judge upon it, which is the best way to go. If the public were really taken into given good facts, I think one could, for instance, what should be our future policy about foot and mouth disease? I mean, as you know, there's a strong feeling that we should vaccinate and so on, and that links in with, of course, the markets and such like. You're right, I think, to emphasise that we have a torrent of choice now, of information coming in. And I think that's not. I think we've reached the point of limited returns now. I really do, and the ease with which one flicks with the mouse from one source of information to another. Of course, a very sinister aspect of the internet, and which is being exploited, of course, by market forces, is that I understand that search engines like Google and so on, they know when you click onto Google what you've been clicking onto lately. And they are apt to, when you click on a subject and it comes up 1, 2, 3, 4, 5, and, you know, 9 pages of Google, but you're going, the top ones you start on, will be able to put the different items at the top of the list for different people. And this is good for marketing, because the marketers will know that they're more likely to see about your project, your approach, and so on. That's pretty frightening. I mean, that's manipulation, if you like. Mm-hmm. But what is one to do? Well, if you start to ration it, then immediately you're in problems again. I mean, China's trying to ration the internet now, you know, and we know why. And one could imagine any kind of forces which are trying to limit it. But I think you're right to the extent that too much choice is not helpful. It's true if you're trying to buy yogurt in a supermarket, and it's true if you are surfing the internet to learn about, I don't know,
I think we have to. Aubrey, we're running out of time, but I mean, we could obviously go on. I'm sorry we don't have time for more questions. It's just been, we're just really getting into the subject. So I think what you have shown this evening is that this interface between science and culture, science and understanding generally, is one which is incredibly important. And it's very, very heartening to hear from the teacher that is beginning to get through in schools. That's really one of the most positive reactions that we've had.